One type of unit that we'll be using a lot in analytical chemistry is the unit of concentration, because generally that's the sort of thing that we're measuring. We're measuring how much of, we're doing a quantitative analysis, how much of something is present in a often solution or other things. So concentrations don't only apply to solutions. You can have concentrations in gases, you can have concentrations in solids even. And so we want to define some of the units that we use for concentrations. So the most common unit that we're going to use for concentration in chemistry is molarity, which is a familiar unit. And we just want to make sure we're on the same page. And I've said that a lot. We want to start from the same point in terms of definitions. Molarity is equal to moles of solute. Solute being the thing that's dissolved in our solution, so the thing that there's less of, divided by liters of solution. All right, and that is a key point to make here, is that molarity, it's a very practical unit because it's easy to measure volumes of total solutions. We have different concentration units that we'll look at in just a second that are defined a little bit differently. One specific type of concentration unit that we use is, say, a formal concentration. This is if we're measuring concentrations of electrolytes that dissolve in solution and create multiple, ions. And this is how many moles did it take to make the solution. So I'll give a specific example, and I think it'll make it clear what the difference is here. So say we have a solution of calcium chloride. So calcium chloride is a soluble salt, so when this dissolves, we actually form one calcium ion and two chloride ions. So the actual concentration of total number of ions will be 3 times however many moles we add in the first place. And if we think about, say, just the chloride, it'll be 2 times the number of moles we add in the first place compared to the calcium. So we need a way to define these that's consistent. And so what we do is we'll define it in terms of the whole formula unit here. How many moles of calcium chloride are in the solution? And then from there we can also define, we could also, if we need to know, we could also get directly the concentration of chloride specifically from that formal concentration by knowing how many chloride ions we get per formula unit that dissolves. So say we have a 1.0 molar calcium chloride solution. That would mean we'd have a 1 molar calcium solution, but a 2 molar chloride solution, since we have 2 moles of chloride for every mole of calcium. Okay, so just as a way of defining that formal concentration. One other concentration unit that is used for solutions that we will pretty much, we use it only a little bit in this class, is molality. And this one is defined as, we usually write it as a cursive M, and it's defined as still moles of solute, so that's the same, but our denominator changes to, instead of liters of solution, to kilograms of solvent. And you may ask, why do we bother with this concentration unit is a lot more cumbersome to use because you have to measure solute and solvent separately and then combine them. Whereas with molarity, you measure how much of something you put in, and then you make the solution and measure the volume of that, and then you have the concentration. So this requires more measurements to get an accurate molality. The reason for it is that molality is not temperature dependent. Molarity will change slightly with temperature because the density of the solution will change. But because molality is defined in terms of amounts of solute and solvent separately, the density doesn't matter, doesn't come into it. And so if you need a unit that is not temperature dependent, this is the one that you use. Okay, so in the next video, we'll look at a few more concentration units for things that may or may not be solutions. All right, so these 2 units, molarity and molality, are specifically concentration units for solutions. We'll look at some different concentration units that are also used sometimes for solutions, but sometimes for other things as well, like solids or gases.